Hey, welcome back. This is Sumit Kumar, and what I'm going to do is I'm going to solve some fixed point theorem questions. Fixed point theorem says that's the topic of real analysis. Okay, so again, this kind of questions are always asking. So question is very simple. They will give you a map from some set to the same set, and they are asking whether this function, continuous or differentiable or homeomorphism, will have a fixed point or not with this domain to this domain. So how one can approach this kind of questions, and most of the students always feel difficulty to finding whether this function has fixed point or not. They will give you some condition, definitely they will give you the conditions, whether this function is continuous, discontinuous, or C infinity, C2 class, C3 class, everything they will give you. And they'll ask the simple question, check whether this function has a fixed point or not. And this kind of questions are like permanent question for TIFR, guaranteed, net permanently, IITJAM permanently. They will ask this kind of question, regular basis. So why not we should confirm, we should be very comfortable with this kind of question. So that at the end we'll be happy. Okay, so that's what I have picked these questions, to understand the fixed point and understand the relation of continuity with that fixed point, to understand the homeomorphism with that kind of fixed point continuity. So let's try to understand this kind of question and how one can deal with it. That's also important. Okay, so let's go. So question here is very simple. Any continuous function, so this is the assignment, which of the following is our false? कौन सा सही है, कौन सा गलत है? That's a simple question. First one is any continuous function from close interval 0,1 to close interval 0,1 has fixed point. ठीक है? Number 2, any homeomorphism from close 0 semi-open to close 0 semi-open has a fixed point. Good. Third, any bounded continuous function from close 0 infinity open, close 0 infinity open has a fixed point. And last option, any continuous function from open interval 0,1 to open interval 0,1 has a fixed point. So now they are just interested in fixed point. They have given some condition on the function as well as they have given some condition on the domain. Whether this domain is compact, whether this domain is closed, whether this domain is open, domain is unbounded, and all that. That's what they are asking. So how one should approach this kind of problem? That's really important. See, solving this problem is not important. I can give the answer for within like 1 second or 2 seconds, but giving answer is not important. Never important. Let's try to learn. In future, if some kind of question, this kind of question they will ask, how I have to approach. That's important. Okay? So let's try to understand. So I always start how to think, how one should approach. That's important. Okay? How one should approach. So question here is very simple. Okay. So first they are asking, they are given you the continuous function. They are given this is continuous. So they are asking, there exists x0 belongs to 0 to 1 such that f of x0 is equal to 0. That means that's what you have to check. This statement is true or false. That's what they are asking. What is the condition? Domain is this, codomain is this, and function is this. Can you have a fixed point? So this kind of question you have already encountered in your elementary calculus or basic real analysis. This kind of question you already encountered. These are the first kind of question where you apply intermediate value property and all that, right? So how should give answer to this question? Okay. So अगर f0 0 हो जाए या f1 equal to 1 हो जाए, we are done. अगर दोनों में से कोई एक भी कंडीशन हो जाए, डन है. सो मान लेते कि कंडीशन नहीं है. डन का मतलब क्लियर है ना? क्या मैं बोलना चाह रहा हूँ? डन का मतलब है कि f0 equal to 0, then I got. If f equal to 1, then I got x0. So fixed point. If suppose दोनों में कोई होल्ड नहीं हो रहा, इसका मतलब बट कोडोमेन मेरा 0 से 1 के बीच में, इसका मतलब f0 जो है 0 के बराबर नहीं है आप, तो क्या है 0 से बड़े, एंड f of 1 जो है 1 के बराबर नहीं है, क्या है 1 से छोटे. Now define this function. 0 1 2 0 1 with the property g of x, not 0 1 2 0 1. Let's define it. Okay, what is gx? Gx is nothing but fx minus x. Define this function. So this function is nothing but this is continuous, this is continuous. So difference of two continuous function is continuous. And what is that? And 0 0 is equal to f of 0 minus 0, and f of 0, what is f of 0? F of 0 is positive. What is g of 1? Is nothing but f of 1 minus 1, and f of minus 1 is less than 0. So at 0 you are positive and at 1 you are negative. So graph is right. So if you draw the graph, so this is 0 and this is 1. So at 0 you are somewhere here, and at 0 somewhere here. So because graph is continuous, so graph must cross x-axis at least one times. So there exists x0 belongs to 0 to 1 such that g of x0 is equal to 0. That implies f of x0 is equal to x0. So this has a fixed point. So you are asking about the false. So this is not false. I know many of you know the answer. I know that, but some of you don't know. That's what I am doing. Okay? If you don't know, it's not a crime. Don't worry. I'm there. I'm always there. I'll help you. And if you know, it's good. If you know it, very good. Okay? So this is got it. How I approach, how to write this kind of question. If this thing happen, done. Write in the language, done. Otherwise, go through this. Okay? Now let's come to the second option. What about the second option? Second option we are saying any homeomorphism. So this is a homeomorphism. So first of all you have to recall what do you mean by homeomorphism. Let me recall. What do you mean by homeomorphism? If I'll say in general, if x and y are matrix spaces, I'll say this map is homeomorphism. First of all, this is homeomorphism. What do you mean by that? Homeomorphism, not homomorphism. Don't be confused with homo and homeo. Homo is for group structure and homeo is for topological spaces. Okay? So this means this function should be bijective. Number one, this should be continuous and also inverse is continuous. If this three condition holds for such function f, then it's called homeomorphism. And also you can check these two conditions plus open map imply homeomorphism. These two conditions plus closed map imply homeomorphisms. Please do, these are the small exercises, please do it. Okay. So now, this you said homeomorphism. Does it imply this has a fixed point? See, if here आप close दे देते, अगर interval ये होता, तब तो डन था, as earlier. But interval ये नहीं है. That's a tricky they have asked. And most of the student has given that wrong answer to this question. They don't have the fixed point. It's completely wrong. Completely wrong. Okay? How am I going to do this? Okay. What will be our approach? So again, if f of 0 equal to 0, done. If f 0 equal to 0, done. Otherwise what? f0 will be a positive. Fine. Now, suppose this function does not have a fixed point. Suppose this homeomorphism does not have a fixed point. Suppose f of x is not equal to x for all x belongs to 0. Suppose, मान लेते हैं, and then we'll arrive at some contradiction. Suppose this thing is not going to be true. इसका मतलब, because this is 1, that means fx कोई भी x आप दोगे या तो ये होगा या तो fx ये होगा. क्लियर है? fx अगर x के बराबर नहीं हो रहा है, इसका मतलब दो कंडीशन, या तो fx x से बड़ा होगा या तो fx x से छोटा होगा. अगर ये हो गया, अगर fx greater than हो गया for all x, then we arrive at a contradiction. Why? Because 0 is not attained. 0 is not attained because f0 is positive and you are saying this map is onto, because this is bijective. So 0 must have pre-image. So this is contradiction. If this is going to happen for all x, means f0 is less than 0. Again contradiction, because f0 is going to be non-negative. How it can be 0? How it can be negative? From here you can derive this is true for all x, means f0 is positive, which is contradiction, means 0 has no pre-image. And here you are getting f0 is less than 0. If you have to make this cases, if fx is less than x for all x, what you will get? So let me write here, so that it will be very interesting. What I want to say, let me write here. Okay? So if fx is greater than x for all x, implies f of 0 is greater than 0. Okay? That means f of 0 is greater than 0. And because this function is 1 now, this function is 1 now, so 0 will not attempt. It will be increasing. Please do this. This I leave as a small exercise. Please do this. Okay? Please. That implies f of x is greater than 0 for all x. 0 to this I leave as an exercise. Please do. Please do. Similarly, अगर fx less than x हो गया for all x, that implies f of 0 is less than 0, which is again contradiction, because f0 belongs to your 0 to 1. So it is always non-negative. How it can be negative? So again we are having a contradiction. So these two cases, this or this will not happen. So for all x is the problem. Might be for some a, b, it will happen, f of a. So this is not going to happen for all x. This is not going to happen for all x. Okay. So let me erase these all two cases. So what else can happen? We only know that fx is not going to be x. You have only given me fx is not equal to x for all x. From this there are two cases. Either fx is greater than x for all x, or fx less than x for all x. So those two cases I have discarded through that. Now one case happened, there exists. If those two cases is not going to happen, then mean there exists a b belongs to 0 to 1 such that a is greater than fn, correct है? And fb is greater than b. That is going to happen in two cases. If that means a, and without loss of generality assume a is less than b. ठीक है? Such that a is less than fn and fb is greater than fb. Or ठीक है? Fine यहाँ तक. Or you can take b is less than fb. No problem. Whatever option you will take. There is no problem, there is no harm at all. Take this option without loss of generality. Assume this. Okay? So I told you there will be two cases. Either this or FA, whatever. Correct? FB. Whatever, it doesn't matter. There will be 2-3 cases. Assume that. So without loss of generality, I am assuming this case. Okay? Take fine. Now consider this function from AB to R. What is that? Gx equal to your fx minus x. So what is g of a? F of a minus a. What is that? F of a minus a, positive. What is g of b? F of b minus b. What is f of b minus b? Negative. So here at a this is positive, at b this is negative, and this function is continuous. By intermediate value property, there exists your x0 belongs to ab such that g of x0 is equal to 0. Because we are taking negative and positive value at well, so 0 value will be assumed because function is continuous and interval is connected. So that implies f of x0 is equal to x0, which is a contradiction. Because I assume fx is not equal to x for all x belongs to 0 to 1, and AB was subset of your 0, so that's a contradiction. Hence, all other cases of this kind you can do this. Okay, I have written only one case, again you can make it. हो सकता है कि FA FB से बड़ा हो जाए, हो सकता है FB B से छोटा हो जाए. These are all elementary cases. Please do this. It will not take more than that. So I have just done one. Then you should write similarly. I can do all cases. So again you will arrive at a contradictions. Okay, done it. So that means our assumption was wrong. So this have a fixed point. Okay. What about this third case? Third case, you are saying any bounded continuous function from 0 to infinity, any bounded continuous function from 0 to infinity, unbounded region to 0 to infinity, function is bounded, right? So that means what you have given, any bounded continuous function from 0 infinity to 0 infinity. So function is 0 infinity to 0 infinity. This function is bounded, right? Don't write 0 infinity. This is like this. This is bounded. What do you mean by that? That implies there exists an correct positive or whatever. Okay? This is bounded such that f of x is less than equal to n for all x belongs to. Okay? Now draw this line y equal to x. Draw this line. Okay? X equal to m is positive number, so m will lie somewhere here. Okay? Okay. If f0 equal to 0, then done. Correct? So suppose f0 is not equal to 0, means f0 is positive somewhere here, because codomain is 0 to infinity, so f0 is here. So now look at this function, and f0 equal to, or f of m equal to m, then done. अगर fm equal to m भी हो गया, then done है. ठीक है, तो भी done हो गया. तो suppose ये दोनों केसेस नहीं होल्ड हो रहे, मतलब f0 क्या है, 0 से बड़ा है, और fm क्या है, m से छोटा है, क्योंकि ये क्या है, बाउंड है ना. तो अगर आप m के बराबर नहीं हो तो क्या हो, आप m से छोटे हो. सिंपल. नाउ कंसीडर दिस फंक्शन fx minus x, where x belongs to 0 से m. Take this interval and define this function on that. What is that 0 0? F of 0 minus 0, f of 0 positive. What is g of m? F of m minus m. What is f of m minus m? It's strictly less than 0, because my fm is not equal to m, so fm is less than m. So fm minus m is negative. Okay? Then after, so that means z of 0 is positive, z of m is negative. So here you are getting positive value, here you are getting negative value. So it will cross your x-axis. So that implies there exists x0, where x0 will belong 0 to m, such that g of x0 is equal to 0. That means f of x0 is equal to x0. Clear? So every bounded continuous function from 0 infinity to 0 infinity has fixed point. So I leave this an exercise. What happened if functions will be like unbounded? What happened if function will become unbounded? Do you have similar some theory? Does it imply it has fixed point? It's very easy. Trust me, it's very easy. So same question you can do for unbounded function. Okay? I hope. मैं आप ही से बात कर रहा हूँ. You should do. ठीक है? So this again have fixed point. So this is not going to be false. लास्ट ऑप्शन बचा, तो मतलब एक नहीं तो गलत होना ही है, ये गलत हो गया. बट वी आर नॉट इन एग्जाम हॉल, राइट? बट वी आर नॉट इन एग्जाम हॉल. लेट्स ट्राई टू एनी फंक्शन दे आर सेइंग, लेट्स ट्राई टू कंस्ट्रक्ट अ फंक्शन व्हिच हैज नो फिक्स्ड पॉइंट. लेट्स ट्राई टू कंस्ट्रक्ट. So let's try to construct a function d, okay, from 0 1 to 0 1 which has no fixed point. Can you give me a function which has no fixed point? Can you? It's my humble request. Can you give? So you are asking any continuous function from 0, 1 to 0, 1 has a fixed point. Well, how one can approach? So it's very easy. Draw some graph. 0 to 1, so here 0 to 1. So I'm looking for a function here which has no fixed point. Okay? Construct a function which has only fixed point at 0 and 1. Take this. Take this function where x belongs to you, open 0, 1. So fixed point means what? You are looking for fx equal to x, that is x square equal to x, that implies x equal to 0 or 1. But 0 and 1 is not our point. So this is a continuous function which has fixed point 0 and 1, but 0 and 1 are not in my domain. And this function has no fixed point in this domain. So this is true option, hence this is going to be false. Hence true. So this is the way to do, Don't be in rush to just to answer the question, okay, these three are wrong, means this is going to be true. Look for examples also. Do you have examples? How I told you, for bounded function it has fixed point. What about the unbounded function? Do we have the similar result? Fine. If we don't, do we have counterexamples? Fine. I don't have counterexample. How I can think those counterexamples? How I can imagine those kind of problems? If you are not able to imagine, don't worry, I will help you. I will definitely help you. Something is written here, think about it. It's only for you guys. If you want to get the quality education, think about it. I'm always with you. Okay? So don't worry, if you can't imagine, no problem. It's not your fault. I will help. Okay? So go through it. If you're feeling difficulty, please write on the comment where you are feeling difficulty. I'll make it sure that so that I can help you in the future. So please subscribe to my YouTube channel if you have not subscribed yet, and like my Facebook page. And for more information about the classes and all, go to my webpage nobleforumindia.com, where you'll get all information about the classes and all. And be happy till then. Study mathematics as much as you can, and surely we are going to meet and do mathematics. Going to do mathematics very well. Okay. And thank you for watching my videos. Work hard in right direction. Direction is very important, and be positive.